So, a very good morning to all of you. And today's interaction basically, it's a kind of interaction between you and me. We'll be talking about are we alone in the universe? And it's a most fundamental question that arises, and it has been there for centuries, that man has always raised a question whether we are alone in the universe. Now, in this interaction, we will not we will exclusively stand in the framework of science. There is nothing that you can correlate with any of the philosophies. I mean, any of the things like religion. So we will be exclusively talking about this topic in the framework of science. So there is no other argument that we would like to entertain in this interaction. And to begin with, I want to state that Earth is a ball, and this ball is in vicinity of the sun, and sun is a star. It's an average star in the Milky Way. You have Earth and you have the star, and in Milky Way you have nearly 400 billion stars. And in the observable universe, you have 2 trillion galaxies. And if I imagine the whole of desert that exists on this planet, and desert means the particles of sand. If you will conglomerate all of the sand that exists on this planet, and you will take just one dot, one grain of sand will make the solar system of the observable universe. So, the number is very large, unimaginable. And as long as our understanding is concerned, we have failed to detect a sign, a signal that could tell us that there is a civilization out there, that there is an intelligence out there. But would it be right that we will exclusively accept the fact that we should be the only biological living creatures in an observable universe which has 2 trillion galaxies? On an average, each galaxy has 200 to 400 billion suns in it. And if you imagine that every star has planetary system as that of Earth, as that of the solar system, then you can multiply the number and you can see that what's the number of the possible planets that may exist in this galaxy and that may exist in the whole observable universe. So this is our target that we would like to talk about. And in persuading this interaction, I will be talking about a mathematical model, a hypothetical mathematical model, and this model was given by Drake. And man has always asked this question. It is not only, this question has roamed in all the frameworks, religions, cultures, different civilizations that we have in this planet. But here, our focus is only science. So, what is the way basically to find if there is anything like this in the universe? We should be able to listen it. And how we can listen? We can listen only through the mark of the predictions of James Maxwell, who predicted the existence of electromagnetic waves. And it's these electromagnetic waves that has led us till now. You have the mobile phones, you have internet, you have any kind of plausible technology in modern time is based on the predictions of the James Maxwell, who predicted that if you accelerate the charge, you can produce electromagnetic waves. And these electromagnetic waves are the only signature we can trace, we can find intelligence out there, life out there, only through these signals. They can be the only source of information for science. And there is no other than that of the signals. And I'm using the word civilization here, because when I talk about the Drake's equation, it gives us a hypothetical idea of how we can calculate that there is a plausible amount of civilizations existing in Milky Way galaxy. Civilization here means an intelligence filled with technology. An intelligence which has technology, and they can send signals, they can propagate electromagnetic radiations. That will be the meaning of civilization when we will be talking about the Drake's equation. So, to begin with, so what is most important is the listening to the universe. And you listen to the universe through telescopes. The Hubble's telescope, the James Webb telescope. The telescopes are the listeners. They listen to the signals that are coming from the outer universe. Now, this is basically an AI-generated image, but the Voyager 1, it is on the periphery of the solar system. It has taken a photograph of the sun. A photograph of the sun, and if you will see the actual photograph, you will find a dot. You will find a dot in vicinity of the star. And you can actually see, you can surf on the internet and you will see the Voyager 1 image. And on that image, Carl Sagan, he reported his own arguments. That see, you take the photograph of a planet which is livable. Okay, there is intelligence, we assume there is intelligence on the planet Earth. There is a range of species existing on the planet Earth. When you take the photograph of the star and you look at your own planet, it's merely a dot. And think about the night sky, where you see billions of stars in the sky. And what is your job? Your job is to find this dot. And this dot is lying in vicinity of that star. Talking about the periphery of the solar system, this distance is nothing in comparison to the nearest star that we have. Right? So they will be, technically speaking, they will be invisible to us unless we have a very, very sophisticated technology so that we can receive the electromagnetic radiations from a planet which is a livable planet that is surrounding the sun. You see, when you will have sun, the luminosity of the sun will kill all other luminosities. It will be very difficult to take even a photograph to a planet in vicinity of the star. Getting my point? So we have a reason here. When we see through the telescopes, We see the light of a star. And if the telescope is not that much sensitive, you will miss all the planets that are roaming around that star. Getting my point? Okay. So this was an idea that I tried to impose on you, that the job is very difficult, but there are people out there and they are working on it, and they are discovering the plausible planets on which there is a possibility of life. And as I said, humanity has always wondered whether life exists elsewhere. And you can find an answer to that question. The number that I gave you, there's always a probability. You cannot neglect that probability when you take into account the 2 trillion galaxies that are existing in the observable universe. I think only a fool will say that there cannot be something like life in the outer universe. And let me be frank enough with you that the life doesn't mean, the intelligent life doesn't mean only the biological one that we have on the planet Earth. Maybe you will have a planet on which the intelligence comes as a result of semiconductors. Maybe the universe behaves in such a way that there is all that we are doing in the laboratories here. Maybe nature is already doing it somewhere. We feel as if we are doing it in the laboratory, producing semiconducting chips, transmitting a lot of information. Maybe there is a life that's already in the form of robots as drone on a planet. You cannot rule out this kind of possibility. Are you getting my point? Okay. So modern science explores this question using astronomy. It's basically the work of all the fields of science. It's not only the physics, it's not only astrophysics, it has to be biology, it has to be the chemical science, because life is all about chemicals. There are chemical reactions going on. And what we say that life on the planet Earth, it has once come to the Earth. It has once formed onto the Earth. Is right now any life forming? A new life? Is it forming now?
A new species maybe.
No, don't say maybe.
Not life. Life is already in here.
Life has been initiated. So you are not having those circumstances that has led to the life on this planet. And it's one of the biggest questions, because you have tried all chemical reactions to produce life in the laboratory, but you fail. You're not able to do it. So is it really true that life has come into complete shape on this planet? Because it seems very difficult. You are failing in your laboratories to bring it back, to create a living creature by doing all the basic chemical reactions. But maybe a lump of life has come from the star, because star seems to be the engine of life. The elements that are existing in our body, metals, Earth cannot make them. Earth cannot manufacture. Maybe a lump, not in a complete biological form, maybe in an intermediate form, it has hit the planet, and then the plausible conditions of the planet has nurtured it, and it has transformed it into a complete biological life. So there are many possibilities that we can think about. I'm not talking about the human life. I'm talking about the life of plants, the life of animals. Right? So there used to have a guiding framework in physics that was Drake's equation. We'll be talking about it. This thing I have already talked about, 2 trillion galaxies, billions and trillions of stars, and Milky Way alone has about 100 to 400 billions of stars. See, it's a billion. See, it's not. It's a billion, 10 to the power of 9. It's a very large number. And we are failing to find it. But that doesn't mean it's not there. So our home galaxy has this much of stars. You can see this image. This is showing the image of the Milky Way galaxy, right? And it's this galaxy, this is incorporating these 200 to 400 billion of stars. And this Milky Way is filled with black holes. And there are black holes at the center of the Milky Way. You fail to explain them that how they are formed. You can talk about a black hole which is other than that of the Milky Way galaxy. At the center of the galaxy, you have a physics of that. But there is a very giant black hole at the center of the Milky Way. You have no explanation for that. So there have had these philosophers, they have speculated. They thought of maybe there exist other worlds. Medieval Renaissance, that the scholars of these have debated the extraterrestrial life that might exist other than that of the planet Earth. And modern science, now it is giving you the tools that you can use these tools to investigate that whether there is life or not. Are we alone in this observable universe? So what life requires? You need chemistry for it. You need energy for it. And you need stability. These are the fundamental things that can build a life. And energy seems to be the most important. Because we fail, the chemistry fails to translate the chemicals. Because the chemicals that are out there, we are made of these chemicals, isn't it? We are made of the same atoms. The atoms that are existing on this planet. This planet is carrying. But you are not able to translate those atoms into a biological life using a chemical reaction. So for that, I doubt maybe a lump from sun has hit the planet, and this lump was an intermediate state of life and the chemicals, and then the planet Earth has nourished it. I don't know, this is my idea. I think about it in this way. So could it exist elsewhere? And we have situations, even on the planet Earth, you will see situations, there are places which are not supportive to the biological life, but still life exists in these regions. So microbes live in boiling vents, acidic lakes, and deep ice, and suggesting life could survive in harsh, terrestrial environments. So life here, you have the proof that life can exist in salty regions, in a region where a common biological life cannot exist. This is also giving us an idea, maybe there is a life which is not purely the way we are looking at it. The life may exist even if the environment is very harsh. Now, what is the most important state for the life to exist is that you want a habitable zone. Now, this habitable zone is also known as Goldilocks zone. That means your planet must be carrying all the important dimensions with respect to the star with which the planet is living. So you have a region around the star where you find the water can exist. You can think maybe there is life. If you are able to detect the radio signals, testing these signals in the laboratory, confirming, because you have a signature. See, a molecule, it has a signature. Water molecule, it has a signature. And if you get a signal, and this signal gives you a signature that there is an existence of water surrounding that star. So Earth lies in Sun's habitable zone, and many exoplanets which have been discovered, they are found in this habitable zone. But you should go back to that Voyager image, and you should realize that how sensitive this matter is. It's not a Hollywood kind of fiction movie in which you're discovering something. No, it's all based on the signatures of the radio signals that you're receiving from the stars out there. So there is a possibility of thousands of exoplanets based on the number that I talked about. And Kepler has discovered many exoplanets, and many are Earth-like in size, and they orbit their respective stars. And this is certainly expanding the potential for life that may exist beyond the planet Earth. So Kepler has discovered. Now this is all mathematical in nature, the signal and then translating that mathematics. And it has predicted a range of planets that are existing around the stars in the Milky Way galaxy. You can see this photograph is just trying to, it's not the reality of the out there, it's the habitable zone that has been discovered surrounding these stars. We have Europa. There is a possibility of life. As we said, that on the planet you have a situation where life is existing, where you don't have all those basic things. So it is predicted that Europa, because it has an ocean inside this moon, so it can be a carrier of the biological life. So these are extremophiles on Earth, as I was talking about, okay? So you find life on the places where these places are not supportive of the biological, but the life is existing in those regions. And as I said, as I started with my argument with the number, and it was Enrico Fermi, he was a physicist, and he came up with a number of questions. Because the number is in your mind, you are able to have a number of the stars that are existing in your observable universe. And this is certainly raising a question in your mind. And Fermi comes up with certain arguments, and we call it Fermi paradox. And he believes that maybe life is common. When that number is brought into the action, the number of the stars. And he predicts that maybe the galaxies that we are seeing, they are filled with the planets, and there is always a possibility of life kind of thing on these planets. So what he says, if life is common, where from the idea is coming? It's coming from the number that's in his mind. Why haven't we seen it? So numbers are telling me the life has to be there, but we are not able to see it. Maybe life is rare. Maybe there are civilizations out there, but these civilizations are short-lived. Short civilization, you understand? I said a civilization which is capable of emitting the radio signals for at least 100 years. Because then you have a chance to detect those signals. We don't know how to detect them. Because this statement is coming in 1950s. So we are far ahead of this paradox. And the Drake equation, basically, it's a mathematical model that was given by the Drake. And this model was proposed by this fellow in 1961 to estimate the number of civilizations. This is a very simple mathematical equation. And in the left-hand side of this equation is the capital N. This capital N gives us the number of civilizations. Now, what do I mean by civilization? A civilization is not something, as I talked about Europa. A civilization is not something like I talked about exoplanets. Okay? Civilization means life with technology, life with advanced technology, life with highly advanced technology. At least they should be able to transmit these electromagnetic waves, which were predicted by James Maxwell. They should be sending signals for at least 100 years in the Milky Way. This equation is applicable to Milky Way alone, because it gives us the calculation of, the hypothetical calculation of civilizations. Now let's talk about these symbols, okay? If we have an equation in front of us, and we would like to know what every symbol that you have in this equation, what does these symbols refer to? What does they calculate? What do you calculate using those symbols? So for that, I have made a pie chart, okay? And you can see that you have R, you have FP, you have NE, FC, FI, and FL. And R is the rate of star formation, okay? How many stars are forming in Milky Way galaxy? Because a Milky Way galaxy or any kind of galaxy, it's not having the same number of stars. There are stars that die, there are stars that are born. So R, star that's there, it gives us the rate of star formation, okay? Then FP is the fraction of stars with planets. So what's the fraction of the stars in the Milky Way that are carrying the planets? Then NE is the number of habitable planets which we are able to, which we have detected to some extent, but we are very far away from the actual numbers. Then Fi is the fraction of life bearing those planets. It is not essential that you have a habitable planet, that means there is life. No, there has to have a fraction of life-bearing planets who can bear the life on them. Then Fc is the fraction of intelligence life. So the Drake's equation is not applicable to all kinds of the life that may be existing in the Milky Way. So here it's purely talking about those planets who have intelligence on them. Intelligence means maybe we have those respective points about these symbols. And the last point, this point is the most important point. If you have a civilization, then what's the length of the communicative civilization? The civilization, as I said, it has to have a communicative, and communicative can be possible only through the radio signals. So they must be able to generate those radio signals. Average rate of star formation is your R star. I'm talking about these symbols, okay? So for Milky Way, the average number is 1 to 10 stars per year. So 1 to 10 stars are formed on an average in the Milky Way galaxy. FP, fraction with the planets. So what fraction of stars have planets? So most stars host planets. So we are receiving those weak radio signals that are telling us that there are planets surrounding those stars. Habitable planets per system, that's NE. Average number of habitable planets per planetary system. Its value is 0.1 to 1. You can have the values only between, for this equation, its value can be only from 0.1 to 1. Then Fi is the fraction where life emerges. So probability life develops on a habitable planet. So on Earth, life appeared quickly, suggesting FL may be very high. Fi is the fraction where the intelligence evolves. So fraction of the planets with life that develops. So you can have a planet having life on it, but they have not developed, there is no development of intelligence. So that means there is no technology, okay? So that cannot be calculated. That has no meaning for the Drake's equation. Highly uncertain. Okay, fraction that can communicate, that's FC. Fraction of the intelligent that develop detectable technology, radio signals. Okay, predicted by James Maxwell. Okay, and we are using these signals, and that's making all this technology possible, the electromagnetic waves. And the last one is the most important one. If you are lacking in this, the Drake's equation fails. So how long civilization releases detectable signals? So that civilization must be transmitting signals. It could be hundreds, it could be thousands, or it could be millions of years. And maybe those signals have not reached us. Maybe we'll detect them. So, assuming this equation, the Drake equation that I talked about, if I take some values, okay, for R I take 5, Fp I take 0.5, Ne I take 1, Fl I take 1, Fi I take 0. When I make the calculations, it suggests me for Milky Way there should be 25 civilizations in the Milky Way. Are you getting my point? Now, if I take another example, using this kind of data you can see, and you can see the numbers are given there. These are hypothetical numbers because there are many symbols in this equation about whom we don't have the data, and we're looking for that data. If we receive that data, we can calculate it. But if we take this data, what it suggests is there is existence of 40 civilizations in the Milky Way. But you understand what civilization means, huh? So there can be billions of planets having life on them, and they may not have an advanced intelligence. They may not have an advanced civilization. Here we are talking only about the advanced civilizations that we can calculate, at least hypothetically, using Drake's equation. It has demerits. Many factors in this equation, they remain uncertain, and results vary by the orders of magnitude. Still, it provides at least a structure. You have an empty structure there that is telling you, come on, you can calculate if you are able to reproduce these numbers in the laboratory. So there are organizations like SETI. It uses radio telescopes to search for the signals that are coming from the outer universe. No confirmed detection of civilizations, expanding to other wavelengths and methods, using all plausible, because you have to choose, you have to go on looking for the different ranges of frequencies that are coming from this silent universe. The universe looks silent to us, but believe me, it's very cruel and very dangerous. We will not live for even a sec if we are outside this atmosphere without a suit, with our ordinary clothes. So it's very, very dangerous. So there are other methods like searching for biosignatures in exoplanets, atmospheres, looking for some megastructures, which we call as Dyson spheres, exploring moons like Europa. So these are different kinds of things but my motivation was basically to talk about those technological point of view. So if we are alone, then it was rightly said by Carl Sagan. What was the argument? What was the argument? The argument was, okay, the mind tells us, the calculation tells us that there must be life out there. Okay, now if there is no life out there and we are alone, and so Carl Sagan says that then we have to be more responsible. We have to be more responsible that maybe we are a starting point for this universe. That maybe we have to be more careful. We have to be more careful to humanity so that there is a plan, and that plan will take us as a life to the other planets that are existing in this universe. So, if we are alone, then we are unique. Humanity is very much unique. So, if we are not part of the larger cosmic community, it's certainly these two things, they raise the question. So, they raise questions about communication and ethics. So, how cautious we have to be about the humanity. But you see, we have wars, we have killings, okay? But if we look outside, there's a hell out of there. And if we are alone in this universe, we have to be more careful to preserve it. But rather, what is happening? We are trying to destroy it. There are all plausible ways used so that it destroys. So we have to be more careful about the humanity. And maybe we are chosen to be the life on the other parts of the universe. So come on, yes? You want to ask me something?
Sir,
If you give me your arguments. I don't
sir,
want.
as you already mentioned that the civilization that must be existing there, they must have the capacity to send signals. But if it is that, is it possible that they must be sending signals that we cannot detect?
Yeah, exactly. That's also possible because maybe they are using a different a range of frequencies which our instruments are not able to detect. Believe me, I'm standing here, okay, and billions of neutrinos are passing through my body. I don't know what's going on. I'm a sensor, but billions of neutrino showers are passing through my body. I can sense the air, I can sense the heat of the room, but the billions of particles that are passing through my body, I have no knowledge about them. So maybe there are signals, but we don't have the detectors that can detect those signals. And that's how the civilization goes. That's how the science goes. They are looking for more and more sensitive detectors. So you're right. Maybe already there's a signal that's reaching our planet, but we are not able to sense it. The way we don't sense the neutrinos, they are passing this planet. They penetrate this planet. And they are real. They explain you the conservation laws in physics. They are real. They are not some kind of hypothetical thing. They are real. They're passing us. Yeah. Anything more? Come on. Did you feel the heat? At least you felt something? Yeah, come on. Any questions? So shall we stop here? Huh? Okay, so with this I would like to stop. I hope we enjoyed. Yeah, you can stop it and let me say goodbye.